Welcome to the Mechanics 1 lesson on constant acceleration equations. The aim of this lesson is to learn the 5 constant acceleration equations and be able to use them to solve problems that involve constant acceleration. Before we get started with the equations, we need to make sure everyone's happy with the terms and the abbreviations used. So there are 5 things that we need to know. We need to know that U stands for initial velocity, V stands for final velocity, A stands for acceleration, S we use for displacement, and T stands for time. There are 5 equations made up with different combinations of those values. So the first equation is V equals U plus AT, S equals a half, then in brackets U plus V times by T, V squared equals U squared plus 2AS, S equals UT plus a half AT squared, and S equals VT minus a half AT squared. The bad news is that these are not given in your formula book, and you are expected to memorise these 5 formulas before your exams. So let's start off with an example. So a car joins the motorway travelling at 8 meters per second and increases speed to 20 meters per second with a constant acceleration of 8 meters per second squared. We want to find the length of time that this actually takes. So let's start by making a list of what we know and what we would like to find out. So you'll quite often hear SUVAT mentioned when we're talking about constant acceleration equations, because they're the 5 terms that we're going to use. So we've been told that the car joins the motorway travelling at 8 meters per second. So that will be our initial velocity. Increases speed to 20 meters per second. So 20 is our final velocity. And it has a constant acceleration of 0.8 meters per second squared. And we've been asked to find the length of time that this takes. So we know nothing about the displacement. So we need to choose an equation that has U, V, A, and T present in it. So we're going to choose that V equals U plus AT. So if we substitute in these values as the first thing, so that makes it 20 equals 8 plus 0.8t, and this is now a simple equation that we can rearrange and solve to find a value for t. So we subtract 8 from both sides, 12 would be 0.8t, and rearranging further by dividing by 0.8, t is going to be 12 divided by 0.8, which we can use a calculator to work out, which gives us an answer of 15 seconds. Let's try another example. So we've now got this time a racing car entering the final straight, travelling at 35 meters per second, covers the 600 meters to the finish line in 12 seconds. We're assuming a constant acceleration, which means we can use our SUVAT equations, and we need to find its speed as it crosses the finish line. So again, we'll make our list: S, U, V, A, T, and then we've got to go through the question and decide which things we know and which things we'd like to work out. So we've been given U, and it entered the straight at 35 meters per second. We've been given S, it covered the 600 meters in 12 seconds, so the time was 12 seconds. And assuming a constant acceleration, we've been asked to find the speed it crosses the finish line, which is V. So we don't know A. So this time we need an equation with S, U, A, and T in it. So we can choose that s equals 1/2 of u plus v multiplied by 2. So again, if we substitute in the numbers first, so we get 600 equals 1/2 of 35 plus v, and then that's been multiplied by the t, which was 12 seconds. So if we just simplify that a little bit first, so we end up with 600 and 1/2 times by 12 will give us 6. So from here we should again be easy able to rearrange to work out v. So if we divide both sides by 6, we'll end up with 100 equals 35 plus v, and then to calculate v we need to subtract 35 from both sides. So v is going to be 100 minus 35, so we can get a value for v of 65, and that will be 65 meters per second. So if we try a third example then. So the barrel of a shotgun is 0.9 meters long. The shot is placed in at rest and leaves the muzzle with a speed of 240 meters per second. This time we're trying to find the acceleration of the shot. So we read through the question and decide again which of the 5 things we know and which things we'd like to work out. So the barrel is 0.9 meters long, so that's our displacement. The shot is placed in at rest. So you expect to know that this term at rest means that we're going to have to use an initial velocity of being 0 meters per second. It leaves the muzzle with a speed of 240 meters per second, so that will be v. And we've been asked to find the acceleration, so this time we don't know the time. So we need an equation that contains s, u, v and a. So we're going to use the fact that v squared equals u squared plus 2 s. So v squared equals 240 squared. U squared is going to be 0 squared. 2as, so it's going to be 2 multiplied by a that we're trying to find, multiplied by the s, which was 0.9. So again, I would always aim to simplify the equation before you carry them any further. So 240 squared you can calculate to be 57,600. That's got to equal 0 squared is just going to be 0. 2 multiplied by a multiplied by 0.9, so we can calculate the 2 times by 0.9 to give us 1.8. That will be 1.8a. So finally, just to calculate a, we need to divide by the 1.8. We've got our 57,600 divided by 1.8. And we can calculate that to give us the value for the acceleration of 32,000 meters per second squared. Right, time for our final example then. So this time we've got a skier pushing off from the top of a slope with a speed of 1.5 meters per second and accelerates at 2 meters per second squared. The slope is 22 meters long. How long does it take the skier to reach the bottom of the slope? So quickly make our list again. So we've been given the initial velocity of 1.5 meters per second. We've been given an acceleration of 2 meters per second squared. And we've been given the displacement in the length of the slope of 22 meters. And we've been asked to find the time this time. So again, we need to choose from our list of 5 equations to find the correct one. So the one that contains S, U, A and T, so we can use the S equals UT plus 1/2 AT squared. So S is 22, U is 1.5, T is the value that we're trying to calculate, so plus 1/2, A is 2, and again T is the thing we're trying to calculate, so we'll leave that in there as 2. So if we just simplify that as much as we can do, so 22 equals 1.5 T, a half multiplied by 2 is just going to give us 1, so that will be just plus T squared. Now what you should notice here is we're actually coming out with a quadratic equation. We've got T squared, we've got a term with T in, and we've got a constant term. So if we're aiming to solve a quadratic equation, we should try and rearrange to make it equal 0. So we can subtract 22 from both sides of the equation to make it equal 0. I'm also going to change the order to write the squared term first. So T squared plus 1.5T minus 22 must equal 0. So this is a quadratic equation, so you would have choices on how you'd solve this. So you may want to try and consider factorising. For mechanics, factorising isn't usually the best idea because you'll quite often have tricky solutions to these kind of problems. They won't come out as exact values, so factorising may not always be the ideal option. So then you could go down the lines of the quadratic formula. So you could use the fact that A equals 1, B equals 1.5, and that C equals minus 22, and substitute those in your quadratic formula, and that would be a perfect method of being able to deal with this. There is a slightly better method available to yourselves if you've got one of the graphical display calculators. So if you have got a graphical display calculator, you can use it to solve a quadratic equation for you. And this is a valid method for the exam, as long as you try and show you're working out accurately. So if you'd like to solve it using a graphical calculator, first you need to enter the equation mode. And you can do this by pressing the menu key and then entering mode number 8. You then need to select the type of equation you'd like to solve, so we're going to choose polynomial because a quadratic is a type of polynomial. Then we're going to select degree 2. If you remember, the degree of a polynomial is the highest power, so in a quadratic the squared term is the highest power. And then all the calculator actually does is it uses the quadratic formula for you if you enter the A, B and C values that we previously discussed. So we're going to enter the A equals 1, B equals 1.5 and C equals minus 22. Then we can press the F1 key on the calculator to solve the quadratic equation, and it will give us two solutions. It gives us that T equals 4 and T equals minus 5.5. Now we do just need to be careful with our solutions. We've been asked to find the amount of time that it takes for the skier to travel from the top of the slope to the bottom. So we should notice immediately that this negative answer isn't going to meet our needs. So we can actually reject this solution because it's a negative value of time, so that's not something we're going to be interested in. So we conclude that our final answer must be that T equals 4 seconds with the time it takes for the skier to travel down the slope. So as a brief summary of what we've discussed, you need to learn the 5 constant acceleration equations. If an object starts from rest, then u equals 0 meters per second. You must write a list of all the values you're given before you answer the problem. Substitute all the numbers into the equation before you then try and solve is a good strategy. And remember, you can use a graphical calculator to help you solve quadratic equations in the final exam. This is a more efficient method. Okay, thank you for listening.